All right, today we're jumping into one of the most incredible, most complex systems in the entire universe, your own immune system. I mean, it's this amazing guardian that's protecting you around the clock. But what happens when that guardian makes a really, really bad call? Let's get into it.
And that's really the big question we're tackling. We're going to look at 3 different ways this system, the very thing designed to keep you safe, can go completely off the rails. We're talking everything from a simple false alarm to an all-out civil war, and even an inside job that threatens to bring the whole operation down. Okay, first things first. Before we can really get into the errors, we need to have a solid picture of how this system is supposed to work when everything's going right. So, I want you to picture your immune system like this elite security force. They are on duty 24/7, constantly patrolling the streets of your body, always on the lookout. They're identifying threats and taking them out, usually before you even have a clue there was any danger. The coordination is just, well, it's mind-blowing.
And this entire force, this whole massive operation has one single absolutely critical job: figuring out friend from foe. Is this cell part of us, or is it an outsider? You can think of it like every cell in your body is carrying a special ID card. The immune system's job is just to check those IDs. If they find anything without the right credentials, a bacteria, a virus, it gets eliminated. Simple, right? It's an incredibly effective system that literally keeps us alive.
But what happens when that security force gets a little jumpy? And that brings us to our first, and by far the most common, type of immune misfire: allergies. An allergy is basically just a giant false alarm. That bit of pollen or that peanut isn't actually a threat to the city. It's just a tourist passing through. But for some reason, the security system totally panics. It sees this harmless visitor, smashes all the alarm buttons, and calls in the riot squad. And that massive overreaction is what we feel as an allergic reaction. Now, the technical term for this is a type 1 hypersensitivity reaction. And the key player, the one really driving this whole thing, is a specific kind of antibody called immunoglobulin E, or just IgE. You can think of IgE as the super paranoid, trigger-happy detective on the force, the one who's absolutely convinced every single tourist is a master criminal in disguise.
So how does a false alarm like this escalate so fast? Well, it happens in 3 steps. First, there's sensitization. The very first time you encounter, say, pollen, nothing really happens. But behind the scenes, your body is busy creating those specific IgE detectives just for that pollen. Second, those detectives go and arm the guards. The IgE antibodies lock onto the surface of cells called mast cells, which are basically walking depots of chemical weapons. And finally, the next time that pollen shows up, it latches onto the IgE and boom! The mast cells just detonate, releasing this flood of chemicals, most famously histamine, that causes all those lovely symptoms we know.
And this is where it gets pretty wild, because the scale of this response can be absolutely staggering. If it's just a local false alarm, you might get a runny nose or itchy eyes, a minor inconvenience, right? But if that reaction goes systemic, if it happens all over the body at once, it is a completely different ballgame. That exact same mechanism suddenly causes all your blood vessels to dilate, your blood pressure to plummet, and your airways to squeeze shut. The system has gone from a minor overreaction to a full-blown, life-threatening crisis.
And this is anaphylaxis. It's the ultimate allergic overreaction, a total system meltdown that is, without a doubt, a medical emergency. The body's own security detail is now actively shutting down the entire city. This is why you hear that every single second counts when it comes to treatment.
All right, so the errors are about to get a lot more serious. We're moving on from a false alarm about outsiders to a much scarier problem, a civil war, where the security force begins attacking its own citizens.
This right here is the heart of autoimmunity. That one critical job we talked about, telling friend from foe, has completely broken down. The security force isn't just targeting invaders anymore. No, it's now targeting perfectly healthy cells in your joints, your skin, your kidneys. It's turning its weapons on the very city it was sworn to protect.
I mean, look at the contrast. It's so stark. A healthy immune system targets real invaders and the outcome is health. In autoimmunity, the target becomes your own healthy tissue. and the outcome is chronic inflammation and damage. The very system built for protection becomes the agent of destruction.
So, what's actually happening here on a mechanical level? Well, a lot of the time, it's something called a type 3 reaction. Instead of a direct, head-on assault, the body makes these little things called immune complexes. They're basically sticky clumps of your own antibodies and your own proteins. These clumps then just drift through your bloodstream and get clogged up in tiny blood vessels, say in your kidneys or your joints. And once they're stuck, they act like a little emergency flare, calling in an inflammatory response that just chews up all the healthy tissue around it.
A textbook example of this is lupus, or SLE. In this case, the friendly fire is happening all over, attacking connective tissue throughout the body, and this leads to this whole collection of symptoms. The famous butterfly rash on the face, incredibly painful joints, and, because those sticky immune complexes get lodged in the kidneys, sometimes very severe kidney damage. It's just a perfect, tragic example of a security force gone rogue.
Okay, on to our final scenario. And this one is different. This isn't a false alarm, and it's not friendly fire. This is a betrayal from within. This is what happens when the enemy doesn't just crash the gates, they get inside the command center.
So just imagine an enemy spy that doesn't just sneak past the guards. This agent is so good, they infiltrate headquarters, they walk right into the general's office, and they take over their mind. From that moment on, every single order that general gives is now designed to destroy the security force from the inside out. That is exactly what HIV does.
What makes HIV so uniquely devastating is how specific it is. It's a type of virus called a retrovirus, and it goes after one main target, the CD4 plus T cells. Now, these aren't your average foot soldiers. These cells are the field generals of the immune system. They're the ones calling the shots, coordinating the entire defense plan. And by targeting the generals, HIV effectively decapitates the entire chain of command.
And the takeover itself is a work of biological espionage. It's brilliant and terrifying. First, the virus latches on and gets inside a CD4 cell. Then it pulls this incredibly clever move. It uses a special enzyme to rewrite its own genetic code from RNA into DNA so it can speak the same language as the host cell. It then slices its new code right into the cell's own DNA, basically hijacking it. The cell is now a zombie factory, forced to turn out thousands of new copies of HIV. And then those new viruses burst out, destroying the host cell as they leave, to go infect the next generation.
And the result of this is just devastating. You see, a healthy adult has a really robust army of these general cells, somewhere between, say, 800 and 1,000 of them, in a tiny drop of blood. As HIV systematically destroys them, that number just plummets. When the count drops below 200, that's what leads to a diagnosis of AIDS. At that point, the security force is so wiped out, the body can't even fight off the most minor infections anymore.
So, after seeing all the ways this incredibly powerful system can fail, the natural question is, what can we possibly do about it? How do we even begin to restore order?
Well, thankfully, the medical approaches are each designed to fix that specific failure. For that massive overreaction and anaphylaxis, we have epinephrine, which acts like a powerful counterpunch, reversing the life-threatening symptoms. For the friendly fire of autoimmunity, we have immunosuppressants, drugs that basically tell the whole security force to just stand down and lower their weapons. And for the inside job of HIV, we have a cocktail of drugs called antiretrovirals that interrupt the virus's life cycle at multiple points, stopping it from making copies of itself.
When you step back and look at it, our immune system is the perfect example of a double-edged sword. Its power to protect us is matched only by its power to harm us when things go wrong. And learning how to manage that, how to dial it up when we need it, and dial it way back when it's overreacting, that is truly one of the greatest and most important challenges in all of modern medicine.
And that really leaves us with a fascinating question for the future, right? We've developed these unbelievable tools to manage these misfires, everything from allergies to HIV. So as our ability to fine-tune and direct this incredibly powerful internal security force grows, what's next on the horizon? Could we eliminate autoimmune diseases for good? Or maybe even train our own immune systems to be the ultimate weapon against cancer? The possibilities are as complex and as exciting as the system itself.